Okay, so let's kind of go over again the normal distribution. All right, well, this is part of the handout, but what we have here, we've kind of talked about this before, is that the normal distribution looks something like this. And we kind of talked earlier about why that is, but think about it like this. This is generally the mean, which is going to be our x bar. And for our Play-Doh discussion, I kind of wanted, or our examples, what I want to show you what I was kind of hoping for. And I'll just put this Play-Doh right here. I would like you all to take either Play-Doh or make some sort of dough or something pliable, and I kind of want you to sort of get it together, and this is what you'll be posting on the discussion board. And I want you to sort of create your own mini little, if I can do this correctly, little normal distribution. And I don't, it doesn't matter how big it is, but what I really want you to kind of get the gist of is kind of to feel the difference here. And if it makes sense, if we had a population and we wanted to kind of just pluck the average person's height or someone out of here, most likely, if you notice, there are going to be more people in this area here, which is kind of like where the mean. And then you have, of course, some people who are extremely tall. Those are going to be kind of on the outliers, this side. Or some people who are extremely short, people down here on this side. But generally, if you take everybody into average, it's sort of the mean. And this kind of leads into what we were talking about earlier when this is, of course, assuming a normal distribution, which is similar to the normal distribution we have here. And when we're going over this for the chapter 4, understand that the total area under here, if I were to sort of, this kind of goes on and on forever, right? At some point kind of reaching here. But this entire area under here, the area is equal to 100%. All right, so this whole area is 100, which means ultimately that if I divide this area in half, or this piece here in half, kind of come down, oops, push this back up, this essentially is just the 50%, all right? Of course, this Play-Doh experiment was supposed to go a lot better than this. I didn't have a lot. But just know that this area, this is 50%, and this is 50%, totaling together, making up the 100. And so when we're talking about the standard deviation, which we already talked about, the spread, small standard deviation, larger standard deviation, we're getting more into this area here, right? And so if you're thinking about this, basically, you're going to have your 1 standard deviation, and this right here would be your -1 standard deviation, your 2 standard deviations, and then 3 standard deviations, -2, and -3. Alright, and you just kind of have to remember when we're talking about the area or the distance and what percentage sort of falls underneath these, know that generally, not generally, but most of the scores, if you were just pulling out people, if I had n equal to some number and I wanted to just randomly select someone, there's probably a 68. There is a 68. Let me go up here. The area from here to here, 1 standard deviation plus 1 and minus 1 is going to be 62.6